Here are the answers for the day 2 warm-up. Nonmetals might need single, double, or triple covalent bonds in order to have configurations similar to noble gases. That is, to follow the octet rule. Draw structural formulas for each. We'll draw these pictures using the same strategies that we used for the day 1 questions. First, figure out how many valence electrons you have to work with. Nitrogen is in group 5A. There are 2 nitrogen atoms. 5 times 2 is 10 electrons. When we make our drawing, we only have 10 electrons that we can show using the dots and dashes. Next, write down the atomic symbols for the elements. Nitrogen and then nearby another nitrogen. Connect those together using a single dash line. That single dash line uses 2 of our 10 electrons. There are 8 remaining. Now go around the outside of the atoms and put pairs of dots with the goal of ending up with 8 electrons surrounding each atom. Those 2 dots, along with the dashed line, are 4 electrons. 6, 8, 10. I've used up all 10 of my valence electrons, 1 dashed line and the 8 dots. The nitrogen atom on the left side of my drawing follows the octet rule, but the nitrogen atom on the right side of the drawing does not follow the octet rule. Right now, it only has 4 electrons associated with it, the 2 dots above and the dashed line. The nitrogen molecule N2 is an example of a molecule in which having a single covalent bond connecting the atoms does not work. To fix this, we'll remove one of the unshared electron pairs and draw an additional dashed line in between the letters. For example, instead of putting 2 dots on the bottom of the N, if instead the 2 dots are shared in between the N's, then the nitrogen on the left side of the drawing still has 8 electrons associated with it, and the nitrogen on the right side of the drawing now has 6 electrons associated with it. It's still not an octet, but it's better than what we had before. To fix this, let's remove another pair of unshared electrons and draw a dashed line in between the letters so that those electrons are being shared. We still have 10 total electrons shown. 4 of them are shown as dots, and 6 of them are shown with the triple dashed line. The nitrogen on the left side of the drawing has 8 electrons associated with it. And the nitrogen on the right side of the drawing also has 8 electrons with it. Both atoms now follow the octet rule. If you're doing your answer in pencil, then instead of scribbling out the dots like I've done with my pen, use your eraser and you'll have a much nicer picture. It also makes a nicer picture if it looks a little bit more symmetrical. So since I have 2 dots kind of on the side of the left nitrogen, instead of putting the 2 dots above that nitrogen, it looks a little more symmetrical if they're also on the side. Question B, carbon monoxide. The 1 carbon atom contributes 4 electrons, and the oxygen contributes 6. We have 10 electrons to work with. Here's carbon, and then nearby oxygen. Start with a single covalent bond and see if that will end up making a correct drawing. That single dashed line uses up 2 electrons, so I have 8 remaining. 2, 4, 6, 8. The 8 dots and the single dashed line are my 10 electrons. The carbon does have 8 electrons around it, but the oxygen does not. So let's borrow one of the unshared pairs from carbon and instead share it so the oxygen gets to count it as well. The carbon still has 8 electrons and the oxygen now has 6 electrons. Let's borrow another unshared pair from the carbon and share it. Now carbon has 8 electrons and so does the oxygen. Once again, a slightly better picture can be made if the dots are not written on the bottom of the O, but are instead written on the side of the O. Question C. NH4 with a positive symbol in the corner is an ion. This is the ammonium ion. Let's figure out how many electrons we have to work with. The nitrogen atom contributes 5 valence electrons. 4 hydrogens contribute 4 electrons. But the fact that this is a positive charged ion means that it has lost an electron. 5 plus 4 minus 1 is 8 electrons. Let's draw this and follow the principle about making it look symmetrical. So nitrogen in the center, surrounded by the 4 hydrogens. Start with single dash lines to see if that results in a correct picture. Remember that all of your hydrogens need to end up with 2 electrons by them, so that the most you can ever even put by a capital H is a single dash line. And the nitrogen ended up with 8 electrons around it. Remember that this did have a positive charge in the corner, so it's typical to draw brackets around the entire structure so that in the upper corner you can indicate that entire thing ends up with a positive charge.